Our next example, again, you may want to write it down because we're going to go to a blank page. It says the standard enthalpy change for the following reaction is. So they're giving us the answer. This is the delta H. It's 178.1. So they're giving us what the overall is, and they're wanting us to find an individual one. So we're going to actually have an X. So if you'll take a second, you can pause me or whatever if you want to write this down, because I'm going to go to a blank page and work it out. Again, blank page. They're telling me that the total is 178.1 kilojoules. That's your delta H. And that equals the sum of your products. And we have, I'm not looking at my equation, but we have 1, and we would look up, this is that, forgot what we're doing. This will be calcium oxide. Calcium oxide. Let me go back. If I look up calcium oxide in the book, or actually it's in the problem, it gives us that it is a negative 635.5 kilojoules plus, and we've got carbon dioxide, which is a negative 393.55 kilojoules. Well, so this is our products. Now we're going to subtract our reactants, but our reactants we only have 1, and we don't know what it is. That's what they're wanting us to look for. So that's going to become my X. We're going to looking for the calcium carbonate. They didn't give it, it's not in the book. So now I'm just going to solve. I'm going to take all of this, which is negative, and I'm going to add it over to the other side. I'm going to pay attention, negative X. See that negative in front of your X? That should be equaling 12.7.1 kilojoules. Well, that's what negative X is. Positive X would equal a negative 1207.1 kilojoules. And that's my answer. You could take this, plug it back in, and see it. So you could always check your answer with these. So this is when you're looking for one of the heated formations in the problem and they don't give it, but they give you the overall. The last type problem. Here we go. I think I'll have room to write on this one. We've got another combustion reaction. The difference between this and the others we're looking at, they're giving me the delta H, but they're not asking me to find one of these individual things. They're giving me grams. And they're wanting to know how much heat could I give off, or could it give off if I burn 4.5 grams. Well, that's not a full mole. If I burn 1 mole of methane, it's going to make this much. If I may burn 2 moles of oxygen, it's going to make this much. It's going to make that much carbon dioxide and 2 moles of water. So the first thing I've got to do is to convert to the mole. We actually did this type of problem in pre-AP, and I'm doing oxygen, which is O2. I would bring grams of oxygen down and mole of oxygen to the top, and this is 32. Normally now it's looking like a stoichiometry. Normally you put the word mole of oxygen down here, and you would be putting mole of something else up here. Well, we're not looking for any of the grams of the others. We're looking for heat, and there is actually a ratio for, you're going to get 890 kilojoules of energy release for every 2 moles of oxygen. So you could actually do what we call a mole kilojoule ratio. There are 890 kilojoules per every 2 moles. Some of you are saying, well, what about the negative? Well, the negative means it's being given off, so that's kind of understood. You could put the negative here if you want, but all that negative is meaning is it's being given off, released. Sometimes the book will say how much energy is released, and because it says the word released, it means that the answer is actually negative. But if you look in the back of the book, you might find it positive, and it's because they use the word release to mean negative. So if you'll do this math, you should find that this is 62.6 kilojoules. And you could say negative, or you could say this much is released, given off during the reaction. So that was pretty much the lesson. I'll click on the next page. The next page, this is your assignment. There's a short reading assignment, and then this is the assignment that they worked on today in class. 27 is like the one we just did. I'm having you omit 57B because it's got a weird sulfur on it, and we haven't dealt with sulfur very much, being an S8. So that's why you're omitting 57B, but the rest of them you'll do well. And this will be due, if you're an A-day student, this will be due on Thursday. If you're a B-day student, this will actually be due on Friday. So I hope you guys have a great weekend, and if you were gone for tennis, hopefully you did well.